den mag ich nicht. Hey, heute gehen wir heim in die heilige Halle, wo wir unsere Ausbildung bekommen haben. Hast du gewusst? In diesen heiligen Hallen und so weiter.
Ich war schon so lange nicht dort.
Eben, hast du dich ja verlaufen auch schon, oder? Du bist schon früher, als du zu mir in die Vorlesung gekommen bist, immer ein bisschen später gekommen.
Ja.
Heute gehen wir ja zum Professor Stojadinovic. Gell, du hast bei dem noch studiert, oder?
Ja, ich habe Baustatik gemacht.
Wie hast du ihn dort erlebt?
Hey, ich finde, er ist so eine angenehme Person. Ich habe das Gefühl, er ist immer relativ so sachlich und so knapp und nicht irgendwie, so Larifari und irgendwie 1000 andere Sachen.
So, jetzt kommen wir langsam an da. Grüezi miteinander, herzlich willkommen bei Baertschi Partner on Tour.
Das ist der Roland Baertschi.
Das ist der Ravinas Riram.
Wir arbeiten bei Baertschi Partner AG.
Baertschi Partner ist wahrscheinlich das einzige Ingenieurbüro, das arbeitet, um möglichst nicht bauen müssen.
Wir erschaffen und erhalten sichere Immobilien für die Zukunft.
Bei Baertschi Partner on Tour treffen wir hervorragende Persönlichkeiten aus der Bau- und Immobilienbranche.
Und heute treffen wir den Professor Stojadinovic von der ETH Zürich.
Er ist wahrscheinlich einer der führenden, oder wenn nicht die führende Persönlichkeit, wenn es um erdbebensicheres Bauen geht.
Seit meinem Studium und meiner Weiterbildung habe ich schon viele Erfahrungen bei BPAC sammeln in diesem Bereich.
Wir wollen den Professor Stojadinovic heute fragen, wieso ist Erdbeben immer noch so ein riesiges Thema? In der Schweiz gibt es doch gar kein Erdbeben. Gehen wir?
Ja. Good morning, Professor Stojadinovic.
Good morning, Ravina.
Good morning, Božidar.
Good morning, Roland.
Thanks for inviting us to ETH Bauhalle, the holy grail of Swiss engineering.
Thank you for coming.
Ja, Professor Stojadinovic, Sie sprechen ja auch sehr gut Deutsch. Ich bewundere, wie schnell Sie Deutsch gelernt haben. Die Vorlesungen halten Sie ja zum Teil auch auf Deutsch.
Zum Teil.
Ja. Und ja, das Deutsch ist wirklich gut, aber wir switchen zu Englisch, damit es uns einfacher geht, uns zu unterhalten. Ist das gut so?
Yeah, that is good for me. Thank you very much.
We prepared a little challenge for you today. You see all those bricks? We have prepared a little tower built on bricks. And we expect you to build a tower which is at least 5 times as high and still earthquake proof, as you are the leading expert in earthquake engineering. This should be no problem for you.
Yes, but you didn't give me any nails.
No. We keep it basic.
Okay.
Božidar, you returned just from Spain and you are traveling on to Singapore in a few days. So even more, it's a privilege to be here. When you are going to Singapore, you are also doing a lot of research there. What are your main research issues in the end?
The center that ETH has in Singapore is one of the 3 large projects that we have there, and the one that I'm involved in is concerned with the resilience of cities. It is about future resilient systems. That is the name of the center, and it has to do with very dense cities like Singapore. But Switzerland can learn from that because the conglomeration of Zürich, Bern and Basel together looks a little similar, and we can learn about how Singapore manages that density and how they are staying resilient with the climate change that affects them, with lack of rain or perhaps too much rain, or other events that may challenge their systems.
Mm-hmm. Please don't forget to build your tower,
Oh.
or you will miss the exam, you know.
That makes it quite difficult then, okay.
So I see your research is not only limited to buildings, to earthquake-proof buildings, but more to societies. So all the society still works after a catastrophic event.
Yes, this is one thing that we have noticed a lot after recent earthquakes. The buildings stay up. Mm-hmm. This is a huge testament to the success of earthquake engineering in the last half a century. Even in the 60s, we had catastrophic earthquakes with thousands of people dying.
Oh.
Of course, now we still have some, but not as many. But we now have earthquakes where no one dies, or very few people do, because buildings don't collapse anymore. The new standards are excellent. Mm-hmm. And new construction done to the best of the standards, following them closely, is of course working. But what we have after the recent earthquakes is stoppages to the society, large losses to businesses, long recovery times. Impatient people, of course, don't want to wait that long. And we are now concentrated on making sure that the functional recovery of the buildings and on the systems altogether is achieved. Not only collapse prevention, but also functional recovery.
So there is where the real money is, even though it's maybe not in the codes and not injured.
Absolutely, that the injuries are and the deaths, of course, are priceless. It is difficult to monetize those, but the real money after an earthquake in losses is in how much you have to rebuild, and even more so, how much business did you lose because you didn't work. And that is quite a challenge to monetize and also to protect.
I mean, you spent a lot of your professional career in California.
Yes.
Where we all know there's a lot of earthquake, Northridge, let's say, and so on. I mean, I understand that we do earthquake research in those places, but how on earth did you get to Switzerland and do earthquake research? I mean, we don't have earthquakes here.
Well, we don't have earthquakes here, but we need the knowledge. We need the knowledge because we sometimes will have a small one, like there was a 4 something a few weeks ago. We may have a repeat of the Basel 1356 earthquake, which would be quite damaging today. Perhaps casualties, but certainly a lot of monetary damage. And so our engineers, Swiss engineers, must know how to do this, must know how to protect buildings against earthquakes. And the other reason is a Swiss engineer is not going to work in Switzerland only.
Yes, maybe we should think to export our stuff.
We do, we export everything else. And knowledge is knowledge. And our engineers have to be competent when they come to Italy, not very far, Greece a little further away, Turkey a little further away, or anywhere else in the world, they have to be able to deal with the challenges of earthquake engineering also.
Maybe you remember we shared some experts. I think one engineer that worked with me was from Greece. She came back every weekend saying, well, we had 2 earthquakes last weekend. And one of her former engineers started a PhD at your chair.
Yes.
And there I saw it's not only the performance of buildings, so how will buildings do in an earthquake, but also how big will an earthquake be, where you had some revolutionary attempts.
Well, I mean, it is difficult to control the size of an earthquake, but it is easier to control the amount of risk that we are going to see. Earth is going to stay like it is for the next hundreds of thousands of years. But the buildings that we build have changed so much over even the past 50, let alone 200 years ago, or several thousand. So we build more, and there is more of us. There is more value that we make every day. And therefore the risk grows, even though the seismic state doesn't change at all. And with that, we have to make sure that we control the exposure, the so-called vulnerability of the buildings, not only one of them, but all of them in a city or a region.
So
and
to
that
say,
takes some thinking and some planning.
So to say it simple, if there is nothing in a place, there will be no damage. But because we have so much things standing in a small place, we have a large risk in Switzerland, which we need to address.
Pretty much, yes. And with every new railway, every new bridge, every new tunnel, every new neighborhood, the risk grows a little bit. But over 100 years, there is a lot building up. And that is what we have to protect. So it is not to say that by the passage of time, the risk will somehow dissipate. In fact, by the passage of time, it will only grow.
Well, I see you progressed quite well with your tower, but it will need something to reach a factor of 5. Ravina, du hast ja beim Professor Stojadinovic studiert und Weiterbildung gemacht. Wie hast du ihn erlebt?
Do you remember me?
Yes, of course, in classes and also.
He always tells me that
class.
he remembers me as the late student.
Well, No, not really. No,
Yeah.
not that way. But it is difficult to remember all the students
of
for
course.
everything, and everything that they did in class. But overall, I try not to remember who came last to the classroom. That is probably the worst thing I could possibly remember. But maybe if you did something good in an exam question or something like this, I tend to notice.
Okay, yeah.
Yeah.
How did you become like a professor? Was it like always a dream of yours?
Well, actually, no, not really. My father was a bridge engineer, and he actually built quite large bridges back in the old Yugoslavia. But in something like, well, he died when I was 19, before I started studying. But somehow I already knew I was going to go to civil engineering, and I wanted to become a bridge engineer. But then, reality kind of sort of strikes, and also opportunity. A friend of mine, he went to do a master's in the US at Carnegie Mellon University. And he came back that summer and said, well, it's really nice, and you should try, and there is an open spot. And I did apply, and I got accepted. And a few months later, I was on the airplane to Pittsburgh, Pennsylvania, and started doing my master's there.
So you didn't want to start with earthquakes? You still?
No, not really. At that
okay.
point, well, at that point, I knew a little bit, because I started working at the equivalent of EMPA of Yugoslavia. And that they had an earthquake testing lab, smaller than this one, but they were testing a prefabricated shear wall component of a post-tension system to construct taller buildings, which was what they had patented. And that was quite interesting. But then when I came to the US, my master thesis was on neural networks. In 1980, yes, it was in 98. Neural networks existed then also. They were a little forgotten in the meantime. Now they're quite popular. Maybe they'll be forgotten too. Who knows? But that was the beginning. And then my advisor, Chris Thibault, came from Berkeley and was very much into earthquakes, and he wanted to do a project on hybrid simulation that had to do with dynamic loading. And while we were waiting for the funding, the Loma Prieta earthquake of October 17, 89 happened. And we knew that there will be a very, very large need for research. And at the same time, he got a position to be a professor at Berkeley. And so then he said, well, would you like to move with me together to Berkeley and do something about the collapse of this viaduct, the double-deck viaduct in Oakland, that had a problem with joints, with reinforced concrete joints and their movement and deformation and shear during earthquakes. And I said, yes, sure, that would be fun. And so in the beginning of January 1990, I found myself in Berkeley and started to study dynamics and all kinds of stuff related to earthquake engineering, and eventually did 8 large-scale tests of knee joints for a bridge. That they're supposed to find a solution to how to retrofit them and fix them. And then it started somehow, and then the Northeast earthquake happened that you mentioned, Roland. That had developed a problem. Buildings that were made out of steel developed a serious problem in their joints. And I was already done, but then Professor Popov, who was a very famous professor, did a lot of this work before he retired, was tasked to do 3 tests to reproduce the failure modes that were observed in an earthquake. And I was there in the lab and able to do this in 6 weeks. 3
Wow,
tests.
that's quick.
That was quick, no sleep. But 2 of those tests reproduced exactly the failure mode, the breaking of the column. And this was a large steel column, full scale. So when it broke, my advisor, who was sitting on the 7th floor of the building, came down and said, what happened? Because they felt a small earthquake. And that was very, very good, because it showed that there was a big problem and that needed to be fixed. And the big project started, and in the same time I got a job, my first job at the University of Michigan in Ann Arbor. And then my colleague Subhash Goel and I got a part of this project to test another 15 steel beam column joints, and had 3 PhD students doing that and all this. and lots of trips to Japan, lots of trips to the big shake tables there to see what they are doing, because they had a problem in steel buildings that developed after the Kobe earthquake in 1995 that was not the same, turned out, but they were still very interested in collaboration and exchange of knowledge in this topic. And so then years passed by. There was a lot of concrete tests, there was a lot of steel tests, and then I got just so much into earthquake engineering, I couldn't do anything
you
else
couldn't leave anymore.
I mean, when you came to ETH, you also had a big testing machine installed. We see behind us. So
yes.
Congratulations to that machine. That's
Yes.
really a huge thing to look at, and it's also very powerful, I learned.
Yes.
How did you arrive in Switzerland?
Well, I mean, there was a time sometime in 2010 or so when I had already become a professor at Berkeley, and in some sense, both my wife and I were in the middle of our careers. Mm-hmm. About 25 years in the US, and so we were looking and sitting at that point in time in our lives and saying, well, okay, this is nice, it works, but is there something else? And somehow the call from ETH came mm-hmm. and said, would you like to interview for this position? And well, we said, yeah, let's try. And it was very, very lucky, very fortunate that I received an offer, and we were supported to come back to move to Switzerland mm-hmm. together. And this was a very good thing for us life-wise, because we learned so many new things and mm-hmm. just a different way of doing things and living and enjoying. Mm-hmm. And certainly ETH is a fantastic school. The equipment that you see, this huge machine, is a testament of how much value ETH gives to a professor and freedom to construct the machines that they need to do their research. Mm. And so this is very, very much appreciated.
Well, I experienced the ETH side or the Swiss side of your appointment as a professor, and I'm very lucky you are here.
Yeah. Thank you.
Wir bauen hier grossartige Türme mit führenden Experten aus der Immobilienbranche. Ravina, die sieht man fast nicht mehr. Wenn wir da mal versuchen, Gebäude zu verschieben. Weißt, wir haben ja andere Gebäudeprojekte, wo wir auch Verschiebungen haben. Ja, mach doch das mal.
Ich hoffe, es geht nicht gerade runter.
Nein, du schaffst das.
Good.
Huh? She can start a new job, right?
Of course. Moving buildings.
Yeah, that should be the new.
Yeah, the movers.
You just told me before that you didn't choose Switzerland per se to come here. Like, how did you experience it in the beginning?
Oh, well, it is completely different than California, where we lived for 20 years. And it is impossible to compare. You just come here and turn on another way of living, slower, more patient, more time to enjoy the nature, more time to think about what you're going to do, how you're going to do it, more reliable in many ways. Mm-hmm. But on the other hand, living in the US and in California is fast and always dynamic, and there is always surprises, and you never know what's going to be tomorrow. So it depends, but people like both and can enjoy both. As I get older, I prefer this way of life. Yeah, what can I do?
For the young years, you were enjoying.
For the young years, it is actually quite good to live very, very fast.
But I think you're still young at heart.
Well, hopefully, yes.
Yeah. You're living in Switzerland. Everyone's house should be earthquake-proof. Is yours?
Well, the one that I'm renting is new and has a lot of shear walls, so I believe it can take a lot of earthquake forces. But there are many houses that our friends live in that are older and made out of masonry, without any reinforcement, and even so with old wooden floors. And those can pose some problems. It is not easy to say if they will collapse, but they will certainly need repairs.
But if you are a single house owner, what would you recommend to such a person? Should I destroy and rebuild my house in an earthquake-proof way, or should I retrofit it, or Should I move out, go to the hotel?
Well, I mean, no, don't go to the hotel. And don't destroy it and build a new one unless you absolutely want to have a new swimming pool, a new kitchen or something like that. But retrofitting, small steps go a long way to reducing risk. Small steps like fixing something on your roof, some of the walls that may fall off your building, because they're high, they're up there is a lot of acceleration. That is the first step that one can do. Second, perhaps securing some of the openings where somebody else had made a door where there should not be one. Those are not that difficult or expensive steps, especially if they're also taken together with the energy improvements that one may want to do in their houses anyway to make heating bills and cooling bills, that will come very soon, smaller.
I have seen you have done some research projects on earthquake retrofitting with sustainable materials such as bamboo.
Well, not bamboo per se, there was also, that is quite interesting, but sustainable materials that not necessarily include cement or steel, but nature-based materials like straw, materials to make construction elements.
You can use straw?
Yes, in a very judgmental way, of course.
Oh, okay.
Not too tall, too tall. Or if you tend to mix straw with, for example, some kind of mud and some kind of hardening agent, that is something that we could do. Colleagues way back when, beginning of 2000s, have done some tests on straw bale buildings. This is the straw bale that one collects to feed cattle after in the winter. Those can be used to build buildings too. They're thermally perfect.
So what you're describing is more or less the sort of building Switzerland knew a few hundred years ago. So those buildings should still be good and the new ones are bad.
Well, I'm not saying that exactly. The really, really old buildings have their problems, but the ones that are made out of old materials and are still standing, there is a very good reason for that, because they were solid to begin with, and there is still something good there. We should learn those lessons, modify them to provide more light, because those were dark buildings inside, to provide more space, to provide more efficiency, more new amenities, and then combine and make a hybrid that is more both modern and also old worldly in the sense of transferring the best ideas.
If I have only one building, I mean, I can care very in deep for this building. If I need to care for a few hundred buildings, where should I start? I can't redo all the buildings or retrofit all the buildings at once.
No, but this is a question for Wohngemeinschaften here in Switzerland. This is a question for some of the banks and pension funds that own buildings and rent them. They own not only this building, but all of them. And then starting with, where do you start? You have to start somewhere. An engineering company like yours, Roland, and yours, Ravina, can evaluate whether this building or this building is better seismically and tell the owners of a portfolio, give them a priority list. And not only a priority list, but what to fix in these kinds of buildings.
So this is exactly what we have been doing for the past 15 years, and I'm glad to hear that we're doing the right thing. And our customers will be pleased to hear that we are selling them the right stuff.
Yeah, I mean, this is the way to go, clearly.
But do you feel like that in Switzerland people look after the safety enough, or do you feel like it's too less still?
Well, I feel that there could be more.
Okay.
There could be more. It depends where you live in Switzerland. In the Valais, in Basel, I think there is more awareness simply because people mentioned or remember some of the earthquakes that happened there. The Valais earthquake, the last serious one was in the end of the 40s. So maybe some people are still alive. But places where there were no earthquakes historically for many, many centuries, of course people are going to say, I don't want to spend the money. But buildings whose motion under sideways loads is also checked by engineer tend to be better and live over a longer period of time, tend to be more robust for anything that can come sideways. High wind and a car hitting a building. all kinds of crazy accidents. But these buildings are simply better than the ones where you just simply forgot to think about an earthquake type of loading.
So
it
you
doesn't
do
mean that
earthquake.
you have to base isolate, do the best possible thing that they do in Japan, but simple solutions are good.
So if you do earthquake safety, you not only do earthquake safety, but also do some more good to your building.
Definitely. You do more good to the building by making sure it can handle earthquakes well. It provides the building with a portfolio of options to deal with forces, not only one.
Great. Well, I see we're slowly running out of bricks. You get my reserve in the end. We are learning those simple design methods at ETH, like lateral force method, response spectral analysis. Those are also in the code. However, we at Baertschi Partner, we hardly ever use those methods because we feel they're much too weak for us. So we try to do something strong like pushover or time history. Is it sensible to just keep buildings as they are, but just using a more advanced design method, because the building doesn't know we're doing more advanced analysis?
Well, the code is made to be applied for a broad variety of buildings, and also by a broad variety of companies. And the more sophisticated companies, of course, are welcome to use better methods to evaluate their buildings. Non-linear analysis, meaning that the behavior of the building is examined beyond the simple elastic behavior by either static or dynamic methods, reveals more about not only the weaknesses of the building, but also its strengths. Maybe there is a hidden strength that the simple method would not exploit.
That's what we experience usually.
Usually that is the case. And even though people are afraid, I will do nonlinear analysis and I will discover that everything is bad. No, not necessarily so. You may discover one weak point, but the rest could be quite okay, and fixing only that point would be good. Or generally what people find out is that the building, is not all that bad at all.
I mean, we often get customer feedbacks. We have a huge problem.
Yes.
Seismic safety is very weak. But in the end, the measures we take to repair the whole thing is like minimal invasive. It's very small, maybe it's just a little steel clamp we add, and then it's done, and our customers are quite astonished on it.
Yeah. It is true. The very small interventions often relieve a lot of risk. It is possible that completely relieving the risk will require a lot of work. But why do we want to go there? Reducing the risk to what we consider acceptable is the right way to do it. We do that when we travel by train or plane. Of course we take a little risk, but we consider it acceptable. When we live in a house, we should behave the same way. Of course, yes, where we live somewhere for 100 years, the risk should be lower than in an airplane. And that is what our code is about too.
So more safety is not always better than just enough safety.
Enough safety is good for not only your safety, but also your wallet.
Yeah, I mean, in the end, it's not only surviving, but it's also life quality that we want to achieve.
Of course, we don't want to invest everything in seismic isolation. We also want to have a nice patio.
Yeah, or a nice dinner for me.
Well, that too, yes.
Excellent.
I think you have to continue. I can't reach up there anymore.
Okay, so you'll do the questioning.
Did you used to play with Lego as well when you were small, or is it like?
Well, there were Legos, and there was also a mechano set, a steel one with screws. Yes.
Okay, and where did you buy the clay one that you?
Well, somehow I saw the clay one in Italy. They had a demo in ISPRA, the ISPRA laboratories, that they were showing how typical brick buildings would behave. And these are Legos that are made out of clay, so they're heavy. Yeah. They're quite heavy. But when you make small models, if they're just made out of normal Legos, they're just too strong, and an earthquake cannot destroy them. But these were very, very good because they had the weight they could simulate the inertia of a real building quite well.
Also use them for experiments?
Well, not so well for demonstrations in class.
Okay.
For a while we had a very small blue shake table.
Yeah.
It's made by a company, but it was blue. And while it worked, we demoed something.
Okay, cool, yeah.
So
you're doing good. You're doing good courses too. That's good to hear.
Yeah, I hope so.
Wir sind da immer noch bei Baertschi Partner on Tour. Towers are getting bigger.
Yes, they are.
As you see, I'm a practitioner, so I'm a little faster and a little more keen maybe. We'll see if that turns out.
You also tend to work more with architects who want something on top of their building. A crown.
We're sometimes slave of architects, yes.
What do you do besides being a professor, hobby-wise?
Well, I mean, both I and my wife, we like to travel.
Okay.
We like to travel, and many places are still places where we didn't see. But here in Switzerland, we visited quite a lot of mountains and lakes. And when we go abroad, we tend to stay for a few more days after, for example, a conference to see something else. And this is what we like quite a bit.
Okay, but do you travel in the eastern part of Europe or
lately no. It has been a lot tied to the Singapore location of our center. So Indonesia and Thailand and China and Japan. Before that, India, of course, a few times. But when we lived in the States, we traveled a lot around the States and Canada. Yeah. Mexico.
So
it was nearby, yes.
Which part did you like the most?
Well, I like living in the west coast of the United States. Because there are the mountains, but there are also the plains and the seas right there. Yeah. So it's a good combination. And it's not as hot and humid as it is in the south of the United States. But there are, for example, we were in Texas in April. They have what they call blue bonnets, a very nice flower that blooms for a few weeks, and we were very happy to see it then.
Nice. Oei.
Yeah.
Dus het
Sorry, I did a little quick start.
That was not fair.
Well, you're distracting me.
I distracted you with.
I mean, the two of us we'll soon start into the final part of our career. Me, of course, even more than you, maybe. If you had one wish or one legacy to give to society, what would this be? From looking at the earthquake engineering that I had done and taught, and what I think is coming in the future, I think it is going to be risk. It is going to be the consideration of risk, explicit consideration of risk that people, businesses, whatever is inhabiting the building, whoever is traveling over the bridge is going to face during the lifetime of that object. And this kind of risk-based design is something that we've done here in Switzerland with this retrofitting code, the SIA 269/8, but it should transfer to all the other codes. Now we're going to adopt Eurocode, which doesn't do that consistently or explicitly, but that is a challenge for the next version of Eurocode or the national modification that the Swiss could do. Risk-based design, risk-based seismic design. So if you're talking about risk for normal people like me, you mean risk is I try to see safety, so I avoid risk.
Avoidance of risk, true, but acceptance of risk. Stating that we are going to make a building that has such and such small probability of something going wrong, and making sure that probability is transparently and accurately computed. On the basis of this, our insurance colleagues can price their product better and cheaper.
I see.
And our users can have a very good idea of what they're buying.
I mean, we can show our users or our viewers, to our other episode, to another episode of Baertschi Partner on Tour, where we've been talking a lot on risk. So check that out on the internet too. For us, I think we should come to a good end, and to a good end, we should test whatever we built.
Yes.
I mean, you have quite a diverse structure, I would say. And I think you're the expert. Maybe you can do Montenegro or Northwich earthquake to these
And
structures.
earthquakes. So maybe I can try to do something first, very
maybe
little.
transverse.
Hoppala!
It's only something
It
secondary.
is very, very small. This
That's
is like
engineering.
a Basel earthquake.
I see you're just checking the natural frequency of that. Oh, that. Oh! But yours was stronger, so I think we need to go back to your lectures.
Well, I hope so. But there is a lesson in this too. Small earthquakes, okay, low risk. Bigger earthquakes may never ever happen. But even then, it shouldn't collapse like ours did.
Well, so, Božidar, it was a huge pleasure talking to you. Thanks again for the invitation to ETH Bauhalle, the Holy Grail of Swiss engineering.
It is. Thank you, Roland. Thank you, Ravina.
Thank you very
Thank
much.
you for offering this opportunity to me and to ETH.
It was our pleasure. Das war es wieder mit Tricks und Gags. Danke vielmals fürs Zuschauen. Wir sehen uns das nächste Mal hoffentlich, wenn es wieder heisst Baertschi Partner on Tour. Auf Wiedersehen.
Tschüss.